Alright guys, hi, I'm back for another video and I've got Tiny Tim with me today. He was very excited because this is one of his favorite subjects. Today we're going to be talking about solutions. Alright, different types of solutions, how to affect different things with solutions. Tim loves solutions because it has a lot to do with biology, the whole idea of osmosis and moving towards the more concentrated solution, all that. So this is right up Tiny Tim's alley. So he's going to be helping us out a little bit today, but it gets pretty complex. Okay, so first let's just talk about what a solution is. Let me grab my blue marker. So we have a solution. Now I'm going to start abbreviating solution, SOL''N. Okay, that's a pretty standard abbreviation. So if you see that, don't be confused. That's just the abbreviation for solution. Okay, first off, a solution is a homogeneous mixture. Alright? To rephrase or to recall from your first year, a homogeneous mixture is a mixture that looks the same throughout. So it looks completely the same. It could be all clear, it could be all blue, it could be all green, it could be anything, but you're not going to have bits or chunks. If you have bits or chunks in the solution, that's called the precipitate. We'll get to that in a second, but it's not part of the actual solution. Okay, usually, and pretty much all the time in this class, usually a solution is an ion dissolved in H2O. Alright, that means that H2O is going to be our solvent for all of our solutions in this class. It could be oil, or it could be a gas, or it could be any kind of thing, but we're going to use water as our solvent, just because it's common, it's a great solvent in general, and that's just one of the more universal solvents in chemistry. Okay, so that's what a solution is. Let's talk about a little bit of the math, and the math is fairly simple in solutions. First off, concentration. The concentration of a solution is measured in what's called molarity. And molarity is abbreviated capital M. Molarity equals the number of moles of my solvent, or the ion I'm dissolving, divided by the total solution in liters. Now there are other ways to measure concentration, but this is the primary one, and that's the one we're going to stick to in AP Chemistry. So the concentration is in molarity, and molarity is moles per liter, or moles over liter. There's one other equation or calculation that you need to know. It's a dilution. A dilution is a proportion. So we start with a concentrated solution and we want to dilute it. We need to dilute it proportionally. So it is the molarity and volume of our initial equals the molarity and volume of what we're looking for. Okay? So let's say I want to make 1 liter of 0.1 molar solution, and all I have is 12 molar. I would type in, or I would put in 12 for my initial molarity. I don't know what volume to add, but my second molarity would be 0.1, and my second volume would be 1 liter, or whatever we said, or whatever you desire. Okay, I do want to try one little practice problem, because solutions generally are fairly simple. I'm not going to go through how to divide two numbers. I'm pretty confident all you can do that. I'm not going to go over how to solve a proportion. Even Tiny Tim can do these two. Alright, and he's a biology teacher, but even Tiny Tim can do these two. Well, let's go to one that maybe Tiny Tim can't do. So let's start conceptualizing this. Let me erase these right here. And let's pretend I have 2 beakers. Let's pretend I have 2 beakers. Beaker 1 and beaker 2. Now let's say in beaker 1, it's a 1 liter beaker. Both of them are 1 liter beakers. And in beaker 1, I have a 1 molar solution of MgCl2. Okay? So in beaker 1, let's say I have a beaker. I'm going to pretend like we shook it, so there are little waves in there. There is 1 mole of MgCl2. Because the molarity is 1, so it's saying it's 1 mole per liter. And since I have a liter of solution, I have 1 mole in here. Because molarity is moles per liter. I have 1 liter, therefore I have 1 mole. If I were to have 2 liters of this, I'd have 2 moles. Okay? In my other beaker, and we'll add some waves there for dramatic effect, I'm going to have 2 molar silver nitrate, or AgNO3. So in here, since it's 2 molar, it's 2 moles per liter. Well, since I have 1 liter, it's 2 moles in 1 liter, or 2 moles in my beaker. So in my first beaker, I've got 1 mole, because it's 1 mole per liter, so 1 mole. Let me write that down. And in my second beaker, I've got 2 moles. Yes, there we go. Now here's where we actually start doing a little bit of a problem. Let's say I mix these 2 together. Now, obviously, if I mix these 2 together, I'm going to end up with 2 liters of something, right? I'm not going to end up with 1 liter, because I'm mixing 1 liter and 1 liter together. I'm pouring it into a bigger beaker, or a bin, we'll say. And a reaction is going to occur. A reaction is going to take place. And I will tell you that I'm going to have AgCl. Okay? I'm going to have AgCl, or silver chloride. Silver chloride is insoluble. That means that it's a solid. It will not dissolve in water. What that means is at the bottom of this beaker, I'm going to have solid AgCl. This is called a precipitate. When I have a solid that comes out of a solution, these are my solutions, they're homogeneous mixtures. When I mix them together and I get a solid forming coming from the solution, that's a precipitate. So I'm going to have AgCl at the bottom, and I'm going to have essentially 2 liters of MgNO3 2. Okay? Now it's 2 NO3s because the charge on Mg is 2, so I have to do my little crisscross method. Remember that from first year or earlier this year? I have a 2 charge on my Mg, so it goes down here. So it's MgNO3 2. Okay. So I've got AgCl down here. I've got MgNO3 2. And I kind of exaggerated the amount of AgCl, or silver chloride. There's not going to be that much. So it's really, the volume's almost negligible. I know here it looks like, well, Mount Everest, but in reality, there's very little silver chloride that actually forms. Now my question is, let me erase this because I wrote it down below. What is the molarity of my MgNO3 2? Okay? What's my molarity? Well, we got to look at this. We got to think of a couple of things. I know that this is a balanced reaction, and that in a balanced reaction, my moles of product equal my moles. Oops, I wrote that backwards. Too bad I can't edit that out. Whoops. My moles of reactant equals my moles of product. So I know if I have 1 mole of Mg here, I'm going to have 1 mole of Mg here. And if I have 2 moles of Cl, because it's Cl2, so if I have 2 moles of Cl, I'm going to have 2 moles of Cl here, and so on and so on. The moles must be balanced. I cannot create or destroy matter. Right, Timmy? Timmy agrees. We cannot create or destroy matter. Okay. So I know that I have 1 mole of Mg. And I have 1 mole of Mg on both sides. Okay. I know that I have 2 moles of NO3. Because it's 2 molar NO3, 2 moles, right? We just talked about that. And, you know, I know what I have with Ag and Cl. I'm not going to list it because I'm not looking for that. I'm looking for MgNO3. Okay? Now, I know that I have 1 mole of Mg and 2 moles of NO3. How many moles of MgNO3 do you think I have? How many moles of MgNO3 do you think I have? It turns out that I have 1 mole of MgNO3. I have 1 mole of Mg NO3 2. Alright? I have 1 mole because I've got 1 mole of Mg, and for every 1 mole of this compound, I need 2 NO3s. So it balances out. I have 1 mole of this total. So I know I have 1 mole. I know the volume is 2 liters. Well, molarity is just moles per liter. It's like almost magic that it was set up that way. So 1 over 2, I have 0.5 molar Mg NO3 2. Okay? The trick is to realize that I've got 1 mole of this compound and that my volumes were additive. Meaning when I mix them together, I add up. I don't just have 1 liter, I have to add them together. Okay, so that concludes our solution lecture. Hopefully this makes a little bit more sense. I understand this problem's a little bit tricky, takes a little bit of thought, but play it again. Tiny will be here to help you out. We'll see how you do. Thank you.